Hello, my dear students. I'm Tantrisar, and I am in this field teaching chemistry for more than 5 years. And believe me, this today's session it is going to be a very important session, very important session. Because in this session, in chemistry, we study what we call as chemical reactions, and for chemical reaction to take place, we have to have mix the reactants with each other. But is the only condition for a reaction to take place is mixing of the reactants? Absolutely not, because this is not only condition. Then every time whenever we mix up the reactant, they should furnish products, but this never happens. Means its accuracy is not 100%, means it does not happen every time. But what is there any rule, is there any theory in chemistry through which we can predict the future fate of the chemical reactions? Yeah, absolutely. We have got a very important theory in chemistry by which we predict the fate of the chemical reactions, means through which if we have a strong approach, if we have a strong hold on this theory, we can directly predict the future of product formation, means we can directly predict whether a chemical reaction will take place or not. And believe me, this session, after almost 15 to 20 minutes, it is going to be a life-changing session. And believe me, have patience with me for more than 15 minutes. You will master this and you will be able to predict what we call a fate of the chemical reaction. So basically, the name of the topic is collision theory, and this collision theory predicts future of the chemical reactions. It tells about all those conditions which are necessary, very much necessary for a chemical reaction to take place. So basically, I have divided this collision theory in two parts: part A and part B. Part B tells these A and B are basically the conditions which, if a chemical, if some sort of reactants, if they follow these conditions, then they will definitely lead to product formation. The very first important condition is going to be that there must be collisions between the reacting species. Suppose I will take an example. I have a container A. I have a container, suppose okay, of some certain volume, suppose V centimeter cubes. Now I have got two reactants A and B. In this means, in this reaction is taking place between reactant species A and B. Now basically we want to form a product AB. But according to this theory, A and B, or this AB formation will take place only and only if these two conditions are followed. The very first important condition is that collision is between reacting species. What does that mean? It means that AB will be formed only and only if A reactant and B reactant, they collide with each other. Means the very first important condition for AB formation is what? There must be collisions between these reacting species. Okay, now suppose this container having a volume of V centimeter cubes. Okay, now in we have A and B reactants. Okay, now AB is formed. Okay, now it clearly means that AB will be formed only if A and B collide with each other. Okay, now it means since reactant species are filled in whole of this container, okay, means there are collisions in whole of this container. Means whole this container, there has occurred, or there are occurring what we called as collisions. Now the number of collisions that are taking place per second, okay, per second, per unit volume, per second, per unit volume of this container, that this collision theory says that represent those collisions by Z. What does Z mean? Z means collision frequency. What does I mean to say? I mean to say that since a product formation AB has occurred, okay, and it clearly indicates that this first condition, at least the first condition, has been followed. Means that A has collided with B. But since in this whole container reaction is taking place, means in this whole container A is colliding with B. Now the number of the collisions that are taking place per unit volume, in unit volume of this container in 1 second, those collisions are called as collision frequency, and this is represented by a factor Z. So what is collision frequency? It is simply the number of the collisions taking place per second per unit volume. Okay, so it clearly indicates that for a reaction to take place, there must be collisions between the reacting species. Now, if the collisions has occurred, then it will lead to product formation AB. And the number of the collisions that are taking place per second per unit volume, they are known as collision frequency. Now, what does this collision frequency mean? Now you know it, what does collision frequency mean, but how does it help us to predict chemical reactions? Let's see. Now, now, you know, this Z, collision frequency, collision frequency. Now, when we calculate the value of this collision frequency Z for binary collisions, what does binary collisions mean? When collisions are occurring between two reacting species A and B. And when we calculate the this value of this collision frequency Z for a binary reaction, it comes out to be 10 raised to power 25 to 10 raised to power 28. Not a joke. It clearly indicates this is a very huge value. Means for even a binary reaction, the value is such a huge value. So, since it is a necessary condition for a chemical reaction to take place is collisions, since for a binary reaction we have such a huge value of this Z, for reactions of higher order, it must be some very much biggest factors of this 10 raised to 25, 10 raised to power 28. It clearly indicates that then there should be always product formation. If Z is such a huge value even for a binary collisions, but does it happens in actual sense? Absolutely not. We have lot of times we mix up the products of even higher order, more than 3 reactants, 4 reactants, but the reaction does not take place. It clearly indicates that then there has to be something missing in the factor number 1, that is collisions between the reacting species. So it actually says that the only condition for a collision for a reaction to take place is not simple collisions, but the collisions must be effective collisions. So what does effective collisions mean? Suppose A and B are colliding and they are furnishing product AB. According to this collision frequency, A and B, the collision that has occurred between A and B will lead to product formation only and only if the collision is effective. What does effective collision mean? Effective collision means that if the reacting species A and B have a certain minimum amount of energy, and that amount of energy is called as, in chemistry, is called a threshold energy. Means product formation will take place only and only if there are collisions between the reacting species, but the reacting species must have what? They must have at least a certain minimum amount of energy, called threshold energy. Then only the collision that has occurred between them will be effective, and that will lead to product formation. So this is basically the very first condition for a chemical reaction to take place. But what is second condition? What does proper orientation mean? Let's see. Now, proper orientation. A and B will lead to product formation only and only if they are properly oriented. What does proper orientation mean? Let's see. Now, in chemistry, we study nucleophilic substitution reaction. I will take a very simple example of nucleophilic substitution reaction. Suppose this is CH3Cl, okay? This is CH3Cl. This is basically a leaving group, Cl. And I have got a nucleophile, Nu. Now, in this nucleophilic substitution reaction, leaving group has to be we have to knock out, the nucleophile has to knock out the leaving group. But how will this knock out this? It has 2 routes to do so. First route is if it directly attacks on this nucleophile. Second route is if it comes from this side and attacks from this side. But what is the preferential route? What is the route through which this actually happens? It can't do this like this, because actually this reaction takes place when this nucleophile, it submits this negative charge or its known pair on the sigma star of the Cl. When it does so, it weakens the CCl bond and this finally leaves. So what does proper orientation mean here? Means this side A root can't be the actual root, but B root is the actual root. So for this here, what does proper orientation mean? That this nucleophile has to be behind this CH3Cl and it must not face it. This actually means proper orientation. So in short, using this collision theory, it says two things for a reaction to take place. One, the collision must be effective. For effective collisions, the reacting species must have what? They must have two things. They must be properly oriented and they must have a certain minimum amount of energy called threshold energy. In short, then it says that rate of the chemical reaction dx by dt, it's equal to z into f. Okay, now f is the fraction of molecules which have got threshold energy, and later on it comes out to be e power minus ea divided by rt. This is the actual rate of the reaction. Okay, this is the actual rate of reaction. Thank you very much. This was a very important class today. Thank you very much.